So just 2 minutes, sir, we'll start.
No problem. No problem.
Yes.
Thank you.
So can we start, sir?
Yes, ma'am.
Yes, thank you, sir. A happy morning to all of you. Learning is the most powerful weapon which you can change the world. In learning, you will teach, and in teaching, you will learn. It gives me immense pleasure to welcome you all on behalf of Department of MCA, SRM IST Ramapuram, for this 2 weeks International Virtual Professional Development Program. Today, we are in day 9. The number of applications of IoT is increasing and IoT research field is expanding. So in this direction, our Department of MCA, SRM IST Ramapuram intends to organize this PDP session on IoT for modern digital era. So without further delay, I welcome Mrs. D. Kanchana, Assistant Professor, Department of MCA, SRM IST Ramapuram, to introduce today's guest speaker, Professor Arun Kumar Rana, Panipat University. Please, ma'am.
Thank you, ma'am. Good morning, all. It's my privilege to introduce today's chief guest, Professor Arun Kumar Rana. He has completed his BTech degree from Kurukshetra University, MTech and PhD from Maharishi Markandeshwar University, Mulana, India. His area of interest includes image processing, wireless sensor network, IoT, artificial intelligence, and machine learning and embedded systems. Professor Rana has well experience with almost 16 years of teaching experience. He has published more than 101 papers in SCI, ESCI, Scopus, and other national and international journals, and also in conferences. He serves as a reviewer for several journals. He has published more than 10 books, and he has attended more than 9 workshops and 9 FDPs. Also, he guided 6 MTech candidates. Many times received international awards from the various international organizations. Once again, welcome you, sir.
Thank you, ma'am. Thank you for the nice introduction, ma'am.
Thank you, ma'am. So the session is over to you, sir. You can start.
Okay, thank you, ma'am. Thank you for the nice introduction, ma'am. Good morning, good afternoon, good evening to everyone. Today I will discuss about IoT for modern digital era data analytics with different case study. And I hope many teachers aware about the IoT. IoT mean everything is going to be smart, like smart home, smart healthcare, smart agriculture, smart building, smart city, smart home, and everything have to connect to the internet so that we can manage from the anywhere. Now, today I will discuss about what is IoT current status and future prospect of IoT, benefits of IoT, application of IoT may be in the field of agriculture, healthcare, defense positions, and Industry 4.0 concept with the data analytics and cloud computing, fog computing for the data analytics in the case study in the agriculture and healthcare and key challenges in the field of IoT. Before IoT, or we can say before Internet of Things, we should aware about the Internet. I will start from the basic of concept of the Internet so that we can approach to the IoT. And Internet, you can see from the slide, when we connect different digital devices to the Internet so that we can share the information like image, audio, video, text, then we will use Internet. But if you want to control some kind of physical device like bulb, AC, fridge, home, building, smart car, anything, then we have to need IoT. In this, you can see all physical devices, yeah, everything like car, smartphone, microwave, washing machine is connected to the internet so that we can control with the help of mobile phone, with the help of internet. This is the basic difference between internet and Internet of Things. You can see internet means to connection of different devices so that we can share only the information. But in IoT, you can see when we have to connect all physical gadgets, physical devices to the internet so that we can control from anywhere with the help of internet. Now, from the basic father of internet, we should know about this. The father of internet is Windsor, who discovered internet and provide facility to the people so that they can share information with the help of internet so that they can save time, money, etc. And these are some basic service of internet as we may aware about the www World Wide Web pages, web browser like Google Chrome, Opera, search engine in the we can say Yahoo. These are the example of search engine and protocol. Protocol being some set of rule to connect with the internet. Like if you want to control all devices of your home, then you have to follow some set of rules so that privacy can be maintained. Hello, hello.
Arun Kumar sir.
Yes, sir.
Arun Kumar sir, your voice is echoing, sir.
Voice not coming, ma'am. Voice not clear, ma'am. Hello. Hello. Now,
Sir, your voice is echoing, sir. It's not clear.
okay.
There is some echo comes. I think, have you connected through two devices or?
No, ma'am. This is earphone, ma'am. There is echo, ma'am, in the sound.
Yeah, some echo is coming. Hello, sir.
Hello. Now clear, ma'am. Yeah, same
Yeah,
problem.
I could hear you, but
This
yeah.
is this might be maybe internet problem. This is only for you, ma'am, or for all user having some echo problems.
Participants can, if anybody facing the problem, is it clear to others?
Kindly ask from the participant. That may be network problem. Ma'am.
Yes, ma'am, it is clear.
Yes. For them, it is clear only. So you can proceed, sir. No problem.
Okay. That could be an internet problem, ma'am.
Yeah, you can proceed, sir. No problems.
Okay. Thank you, ma'am. Protocol may be the security of the device. We need some set of rules. So we need protocol and next, internet protocol. There may be the IP address to connection the devices with the internet. DNS with like domain name servers like the .in is for the India, .pk for the Pakistan. This is the domain. This is a basic knowledge of the internet. So before the IoT, HTTP, this is a hypertext transfer protocol for the designing of the pages, and email very well know about the electronic mail for the sharing of the data like image, audio, video, text with the help of internet. News groups for the information and video conferencing like this lecture I am delivering. This is possible with the help of internet. Again, this is some basic knowledge of internet, like type of networking, like local area network. For the large geographical area, there is a wide area network. For city, there is a metropolitan area network. And within a campus, if there are different buildings, if you want to connect, then there is campus area networks. And in home, like we are using smart home, then in smart home, every device have to connect to internet so that we can share the information. Now, what is IoT in actual form? Before the discussion of this, I will play one video, very interesting video, which will clear everything. Then in the video, you will see how everything is connected to the internet and controlled by the sensor, controlled by the internet. In this, you will see home, kitchen, car, hotel, office, everything is connected to the internet. Ma'am, video is visible, ma'am? Kindly confirm me, ma'am.
Yes, sir, it's visible.
Okay, thank you, ma'am. Now in this video, you will see a different function of sensor and how data is collected and how data is processed by the sensor and produce the results. This is smart kitchen. In this, you will see the function of IoT sensor, how to manage the data and how to process the data by the users. This is smart car sending information about the status of the car to the user. This is smart office, so we can say IoT mean everything have to connect to the internet. This is another meaning of the IoT. And this is only possible with the help of data. This is the power of data. Data is transferring from one place to another place so that data can be managed with the user with the help of app, with the help of smart devices. this is about the security. Security, how user can access any information with the help of Wi-Fi devices. This is IoT with machine learning. Yeah, we can say with the help of AI, so that we can recognize the person and process the data and produce the output. This video, I hope everything clear about the IoT, how everything is connected to the internet and produce the data and data processed by the cloud and then produce the result to the users. In this, what is Internet of Things? In this, you can see connecting everyday things. In this, you can see there is smart home. In smart home, there is smart bulb, smart AC, and smart security. And this security is connected to the cloud processing the data and produce the data and transfer the data to the user. And user may be anywhere in the car, in the home, in the anywhere. In this, you can see connecting everyday things like smart TV, smart bulb, smart AC. You can see in the advertisement in daily, the device is connected to the internet, and these devices, in short form, we can say embedded. And embedded mean here the combination of hardware plus software. If you're having some kind of smart devices, this means this is a combination of hardware and software devices, and with electronic software and sensor to the internet, enabling them to collect and exchange the data. This is the basic definition. Yeah, you can say this is the core definition of IoT. And this is the father of IoT who discovered Internet of Things, Kevin Austin. Now I will discuss our basic history of the IoT. And in this slide, you can see Norman Joseph Woodland invented barcode. We know very about the information of the barcode. Barcode just give the product information. Whenever we scan the barcode, then we will get some information like date of expiry about the manufacturing. He obtained his idea when he drew 4 lines in the sand and at the beach of Miami. Then next is head-mounted display devices. This is very basic to get the information. Then next is first wearable computer inside a shoe, so that we can monitor the position of any user with the help of this wearable shoes. Now wearable computer with eyeglass mounted display device is very aware about this. This is for playing games, so that we can enjoy the moment with the help of this device. And in 1973, a very first discovery was RFID tag, and Mario Cardillo received the first patent for developing RFID tag. And we aware about the RFID. This is radio frequency identification tag, like fast tag. Yeah, we can say smart card. debit card, there is RFID tag for the information of the users. And after 1973, next development, early 1980, there is a Coke vending machine to monitor the number of bottles. And in late 90, there is a connected device to the RFID technology at the Auto IT Center at the MIT. This is Kevin Ashton who discovered about the IoT, how we connect these RFID devices to the internet. And in real research started in 2004, in this there are major publication to the potential of IoT such as considering home, lights, switches, home healthcare, and shipping monitoring. Then we can say the real research started in 2004, so that different projects can be developed, like in the field of smart home, in the field of healthcare, in the field of agriculture. This is the history of IoT from RFID tag to the IoT. Now, in this, I will discuss about basic building blocks of IoT, what kinds of blocks needs, so that we can design some kind of smart structure. Very first requirement is end devices, node, sensors, yeah, we can say hardware. Like if you have smart AC, smart bulb, smart home, this is example of end devices. You can see from the slide, smart car, smart AC, smartphone, smart computer. These are end devices, so that we can connect these devices to the internet with the help of gateway. Yeah, we can say local processing node. These devices is now connected to the internet. This is the next building blocks. And then after connection of internet, there is need of connectivity and communications. If there is no communication, no media, then this is not possible to connect end devices, yeah, we can say smart devices to the user. So very first end devices, then gateway, yeah, we can say internet, and then connectivity and communication. And next one is software. Software is a very important part. Software function like operating system, yeah, we can say protocol. These are some protocol, yeah, we can say operating system, Mantis OS, Tiny OS, Contiki OS. These are the operating system for designing virtual environment of the nodes, and in this software we can see how the data is transformed from end devices to the cloud, and how the data can be managed by the devices. And next one is the cloud. Cloud is the very important technology nowadays, because we have to store our important data so that we can access from anywhere. With the help of cloud, this is possible. And we will discuss later about the clouds and also about the fog computing. Now, in this slide, you can see sensor and other hardware. In this case, you can see there every type of sensor is present that can be managed by the IoT device. Now we can say this is chemical gas sensor, sound sensor, humidity sensor, motion sensor, position sensor, presence sensor, accelerator, electric magnetic field, leakage. Every kind of sensor is present, so that we can manage. Now, what is the sensor? What is the definition of sensor? As the name suggests, sensor means collection of the data. So the data can be converted and can be processed and can be transferred to the actual user. A sensor detects the change in the ambient condition or the state of another device or a system, and forward or process the information in a certain manner. Sensors, they perform some input function by sensing or feeling the physical changes. Physical changes, like if you want to measure temperature, then there is need temperature sensor. If you want to measure pollution, there is need pollution sensor. So every kind of sensor is required to measure any kind of condition, so that we can convert this kind of physical environment into electrical, so that electrical data can be processed by the devices and processed by the sensor. Now, sensor types: analog sensor and digital sensor. Analog sensor, like the continuous varying situation. Continuous varying situation like temperature, pollution, humidity. For these kind of parameters, we need analog sensor. And for switching, if you want to switch any kind of device, like if you want to switch on your AC, your bulb, or we can say self-driving car, you want to on and off, then there is need of digital sensor. Like 0 and 1, 0 mean off, 1 mean on. Now, analog sensor, in detail, we can see in the slide, analog sensor produce a continuous output signal or voltage, which is generally proportional to the quantity being measured. Here, quantity may be, you can say, temperature, speed, pressure, displacement, strain, etc. If you want to measure these type of parameters with the smart devices, then there is need of analog sensor. And digital sensor produce discrete digital output signal or voltage that are a digital representation of the quantity being measured, as discussed earlier. In this, we have to just on and off the devices, then we need some kind of 0 and 1 data have to transfer so that we can manage the devices with the help of digital sensor. Now, sensor type in broad form, we can say this light sensor, temperature sensor, force, position, speed, sound, chemical. These are different types of sensors. And the component of IoT device like things, like any kind of physical device, then need local network, then internet need, then backend service, so that we can connect the devices to the user, and application so that we can manage the device. This is the function of components. Component of interaction and communication with the IoT devices, component of processing and analyzing of operations, component for internet interaction, component for handling web services application, component of integrated applications with the different service and user interface. Now this is example of IoT implementation. If you want to implement any kind of project with the help of IoT, in this slide you can see there is patient, and patient body having different kind of sensor like blood pressure, ECG, pulse oximeter, EMG, motion sensor. In this, the sensor will collect the data will transfer to the gateway, and then transfer to the base station, and transfer to the internet. And via the internet, yeah, we can say via the cloud, medical expert can use the information and can access any kind of data of the patient. There is no need to move one patient from one location to the another location. Only IoT have to make solution for this problem. IoT provide the sensor provide the data have to transfer to the internet and to the medical expert. In critical situation, medical expert will call to the patient to the hospital. Now, IoT service oriented architecture. In this architecture, we see there is different kinds of layers. Like in internet are different kind of OSI model. On OSI model was the 7 layer, but in IoT there are 4 layers for the accessing of the information. From the bottom you can see sensing layer. Sensing layer, as the name suggests, the function of sensing layer with the help of RFID tag, intelligent sensor, RFID reader, BLE device, and WSN. This is the layer where actually we are just deploy some kind of sensor, physical sensor, for gathering the information, and then information is transferred to the network layer. This is the next to the sensing layer. In the network layer, you can see if you want to transfer data from one location to another location, there is need of network. This network provides the connection, provides the processing of the data to the upper layer, and this is service layer. Service layer just manage the data, like presentation of the data, security of the data. This is a function of service layer. Now, after the service layer, then data is provided to the interface layer. Yeah, we can say this is the layer where a user can actually access the data with the help of application, with the help of contract interface, the application API. So this is the standard format of the IoT service oriented architecture, where you will see smart devices, then the devices will follow this kind of architecture. These are about the IoT categories. In this, even industrial IoT, consumer IoT, you know, nowadays every devices in industry is going to be smart, so that can be automated, so that we can manufacturing and can produce the result and transfer the result to the user. In this, you can see IoT device connect to the IP network and global internet communication between the node done using regular as well as industry-specific technologies. And in consumers, you can see IoT device communicate with the locally network devices. Local communication done mainly via Bluetooth, Zigbee, and Wi-Fi. and generally limited to the local communication by a gateway. Now, this is very interesting. The function of gateway is to connect local network to the global network. And in this, there is a software in the mid of local network, global network. The function of software is to provide switching. Switching means providing the transformation of the data. Data may be in the form of packet, and then data will transfer switching from one node to the another node. Then routing. The routing is the very important parameter so that packet can find actual path of the transformation of data from the source to the destination. Then protocol conventions. So protocol conversation, in this, the protocol is decide the route and decide the path and provide the security with the help of firewall. And after the firewall, there is security to secure the information like IP address, like information, like banking information, any kind of information is secure with the help of protocols. And processor, the function of processor, we know very well processor needs some kind of input and process the input and produce the result and transfer to the other kind of devices. This is the function of IoT gateway to manage the all kind of information. Now this is AI, ML, IoT, and nowadays we very well know all intelligent devices having feature of AI, ML, and then these devices connected to the internet. And AI, ML, and Internet of Things are among the hottest topic in the recent time, gathering a lot of attention from the technology domain. We know if we have Alexa device, smart bulb, these devices can having feature of AI and ML, so that we can pass the information, they process the information and produce the result. And our function of IoT is collect the huge amount of data from different environments. Like if we have data, then data have to process in smart manner. For this, there is AI and ML uses data science to convert the gathered data into important information and use the analytics to the data for the decision making. Like an Alexa device having full features of AI and ML. AI means we transfer some kind of command and the command accepted by the devices, and with the help of machine learning, and the device produce some kind of result, and this result is only possible this with the help of IoT. Mean if you having Alexa and Alexa is not connected to the internet, there is no possibility of AI and ML. So we have to use AI and ML with the help of IoT so that we can create some kind of result. This is some features of IoT with the help of AI and ML. This is in this slide. You can see their data center, some IoT enabled homes, IoT enabled cities, airplanes, factories, and these are some devices having AI ML features. So I mean to say AI ML is only possible when these devices is connected to the IoT, and IoT will manage the whole feature of AI and ML. Now there is some technology with the IoT, there's big data, cloud, smart grid, IoV, Internet of Vehicles, machine-to-machine, M2M, telemedicine, cyber physical systems, 3G, 4G, 5G, SDN, software-defined network. I mean to see every technology, yeah, we can say emerging trends have to process with IoT. If IoT is not used, this is not possible to execute any kind of emerging trend. So this is a big feature. Yeah, we can say the IoT is the backbone of all technology. Now in this, we will discuss about industry education 4.0. This is very important slide. In this slide, we will see the history of the all smart devices and how the devices started from lower position to the higher position. In this slide, you can see first, yeah, we can say 1.0 revolutions. There was total mechanical system, only manual system, steam power, steam engines. There was no electricity in 1.0, yeah, we can say first standards. There was no AI, no computer system, totally mechanical system, manual system. And after first, next one is 2.0. In this 2.0, you can see there is technological revolutions. Electricity introduced in 2.0 education industry system. Now electric train started in 2 4.0 education system, but there was again lack of computer system, IT system. So this was the big problem. To resolve this problem, next one is 3.0 education and industry system. This is the digital revolution. Now in this revolution, there is a total generation, productions of computers and IT system so that machines may be automated without the user. So this is digital revolution where computer system, IT system introduced, and now 4.2, we can say industry education standards. This is the present era. In the present era, we are using IoT, machine learning, deep learning, data science, cloud computing, blockchain. So this is the very important scenario where M2M is possible. M2M means machine to machine, man to machine is possible. So I am repeating again, 1.0 was total manual system, 2.0 mean electrical system introduced, 3.0 mean computer and IT system introduced, 4.0 mean present era where we are using all emerging trends as you see from the slides. After the knowledge of 4.0 education and industry system, we are able to design robot. Now in this slide, this robot is only possible with the help of technique, robotics, artificial intelligence, sensors, 3D printing, big data, software as a service, algorithm, etc. If you are aware, if you are having knowledge about these trends, then you are able to design a robotics. Now this is industry 4.0 value chain. In this you can see the IoT is playing main role from the starting. There is the design, there is the product memory, and after there is 3D printing, and then robots working for designing the main processing of the devices so that actual devices can be generated. This is the actual car produced by the industry 4.0 value chains. Now you can see there is the role of IoT is enabling manufacturing with the help of IoT. Robots doing automation, and from the remotely user can get information about the processing of the product from the start to the end, and service maintenance, IoT operations, and these devices is all connected to the cloud, and cloud playing the major role, cloud securing the data processing and result, how these devices processing from first stages to the last stages. This is the impact of industry 4.0 with the help of IoT to transform the data. Why this field? You know very well now robotic is the backbone of the industry, and we can say backbone of the education system. And these are some industrial robotic applications. You can see there is designing of IC, placing of IC, manufacturing of car, cleaning in hotels, everywhere nowadays robotic is used with the help of IoT so that devices can be connected. This is another example of industrial automations where you can see different kinds of robots, and these robots synchronize to each other, and these robots also connected to the internet so that outcome is transferred to the users. So Boston Dynamics, this is AI robot. Now I will discuss about cloud and fog computing, because if you want to connect any kind of devices, then you have to know how the data process in between the user and between the application. Then there is one form of storage, this is cloud. And in this slide, we will discuss from standalone PC to the cloud-based IoT. Now you can see here first phase. In first phase, there was only standalone computer. Mean this is computer having only data and some application for the execution of the data. Now, by the time data is increased, now data is accessed by the browser. Now, this is the second phase where data can be browsed by the user. And this is third phase. In the third phase, you can see this is the cloud. Now, cloud introduced. After the cloud introduced, data is stored in the cloud. Also, app are stored in the cloud. This will enhance the efficiency of the system. And now this is the present scenario. In this scenario, you can see cloud is connected to the all physical devices like truck, home, building, healthcare, sensor. So this is the fourth phase where all physical devices is connected to the cloud so that you can access your devices from anywhere with the help of cloud. This is the feature of the devices. Now difference with WSN. This is the cloud difference with the WSN. In left side you can see there is only one user and the user having a different kind of sensor nodes. The function of sensor node to gathering the data, aggregate the data and transfer to the user. But there was the problem. Problem is only single user have to connect to this WSN scenario. But in case of cloud computing scenario, sensor cloud, you can see these are the sensor. These sensor is connected to the cloud and multiple user, yeah, you can say multiple application can be accessed by the any kind of user. This is the feature of cloud. And now introduction of fog computing. Fog computing, yeah, we can say fogging is term coined by the Cisco. The idea of fog computing is to extend the cloud near to the IoT device, because in cloud computing every time data have to transfer to the cloud, then cloud process the data and then produce the result, then transfer to the again to the device. This was the problem. This was the time consuming. So to resolve this kind of problem, there is fog computing. I mean fog computing, yeah, we can say fog is placed between the IoT device and cloud. The prime aim solve the problem faced by the cloud computing during IoT data processing, intermediate level between cloud and devices. Now here you can see fog is placed between the cloud and devices, and this will reduce the latency, increase the efficiency of the device. And you can see here why fog computing is used. In cloud computing, some fog issue was like volume, latency, bandwidth. To resolve this kind of problem, there is fog computing. Now you can see here, this is cloud computing. And in this, you can see there are some devices like CCTV camera, smartphone, self-driving car, and the smart ambulance. In every time, data have to transfer to cloud, cloud process the data, and then send back to the devices. So this was the problem. This was the time consuming. To resolve this problem, there is fog computing, and you can see here, fog computing means the device have to connect with the fog, not to cloud every time. Every time data is managed by the fog, and you can see fog is very much near to the devices. And now data analytics is possible with the help of fog in smart manner, so that that device can be controlled. Now, for example, like self-driving car, if there is some kind of person in front of self-driving car, then data have to transfer the cloud. Then after the cloud, data will again transfer to the self-driving car. This is time consuming. So this to resolve this kind of problem, fog is implemented with the device so that immediate action can be taken to resolve many problems like latency or bandwidth. This is the advantage of fog: security, better security, low operation cost, because the fog computing provide with the devices, so low operation cost. Data processed in the fog node before sending to the cloud, reduce the bandwidth and the consumption. Now we will discuss about the device who will take care of the data, who will process the data, who produce some kind of result. This is Arduino device. In this device, you can see there is different kind of pins so that we can process the data and produce the result. In this, there is analog pins. The function of analog pins to process the analog quantity, we can say like temperature, humidity, pollution. These kind of sensor have to connect these analog pins. And now there are digital pins. Digital pins, we know very well, this is for the switching. If you switch on and off any kind of devices, then sensor have to connect the digital pins so that we can process the information. These are some features of Arduino. This is a very simple. Other than Arduino, there are some other smart devices like MC Node, Raspberry Pi. These are more smart devices, but I will just show here basic devices so that you can get some knowledge. This is open source devices, except analog and digital signal, no extra hardware required. With the help of these devices, you can design thousands of projects. These are types of Arduino boards in the markets. This is about the Arduino board. In this, you can see different features like operating voltage, 5 volt, clock speed, 6 MHz, digital input output pin 14, analog input 16, PWM 16, UART 1 interface. So this is about the basic feature of these devices. This is about the detail, how we can transfer the data, process the data with this Arduino board. This is about the again software. This is about the setup for as I discussed earlier. IoT system is embedded system, and embedded system means we need some kind of hardware, some kind of software. So Arduino, Raspberry Pi, MC Node, these are the example of Arduino smart devices, and there is some kind of software to program these devices, which is Arduino IDE. The Arduino IDE software is open source. You can freely download from the net. This is the screenshot of this Arduino IDE software. In this, you can, with the help of different commands, you can design program and transfer this program inside the Arduino device. This is the structure of program. Basically, in smart devices, there is two types of programming model used. First is void setup, and second is loop. I mean to say, program will be divided into two parts. First one is setup, second one is loop. In setup, we have to define the number of pins at which pin sensor is connected, and in loop there will be processing of the data. This is the basic example of LED blinking. This is connection of the small project. In this, you can say this is LED is connected to the digital pin, and when we give 0, this will off. When we give 1, this will off. Here we can say low and high. In this, you can see this is program divided into two parts, setup and loop. Every kind of project from low to high project, there are two parts, setup part and loop part. Setup, in this setup, there is pin mode, mean 12 pin is output pin, where this is connected on the pin number 12, where we can switch on and off this pin with the help of loop. In this, you can say there is 12 number pin is high. This means LED will on. After 1 second delay, this is 1000 millisecond, 1 second delay, this LED will be off. Now, this is a basic simple program where we are using some kind of program processing the result, producing the data. Now you can see here the pin number 12 LED on and off according to the program. This is the link where we can download the software. This is Arduino IDE software, open source software you can freely download. Now in this slide you can see connected devices in billions in 2022. You can see 2022 number of connected devices 11.57. This is 11.57 connected devices, and we know the population of world about 7 to 8 billion, and devices is more than the population of world. And in 2030 you will see the devices will be 25.44 billion. The exponent form the device is rising, so there will be huge market and huge jobs in the field of IoT. Now benefits of IoT: efficient resource utilization, minimizing human efforts, save time, development of AI through IoT. Now application smart home. Smart home mean everything like your fan, your bulb, your AC, your fridge is connected to the internet. Manufacturing, smart transportation like self-driving car. Agriculture, smart buildings, and smart healthcare. These are the basic application of IoT nowadays. and IoT is going to be expanded every day. Everything is going to be connected to the IoT. Now this is big bridge and very difficult to monitor the position and some parameter of this bridge. This is only possible with the help of IoT. Now you can see a different kind of sensor attached on the bridge, and then data transfer to the cloud and then transfer to the monitoring person. So this is another good feature of IoT to monitor the IoT devices. Now for weather monitoring station using IoT devices, we know if you have some value of temperature humidity, then we can able to measure the weather conditions, and the Raspberry Pi devices for the processing of the data, PNC viewer, the cloud, and these are the some scenario to measure the weather conditions. These are popular devices in the market: Google Nest, Philips Hue bulbs, Green IQ controllers, and smart baby monitors, Fitbit band. These are the popular product in the market to share the information. These are IoT working groups. We should have some knowledge about the IEEE standard. This is a very, very important IEEE standard. We are using Wi-Fi. We are using Wi-Fi and Bluetooth devices. These are devices are manufactured by IEEE standards. Now we can say the frequency and the range is decided by the IEEE standards. And this is another IoT BT, now the cloud information, open system connectivities, IoT for the security, for internet task management, for industry. These are the major standards working for the designing of the device, for controlling the data, processing the data. Now this is the case study. In this case study, I will discuss about how IoT enable agri-sensor nodes is used for the data processing. Now in this scenario, you can see there is agri-sensor nodes. Agri-sensor node is placed in agriculture field, and these are different agri-sensor nodes. And the function of agri-sensor nodes is to collect the parameter like microclimatic parameters, air temperature, soil moisture, soil temperature. So this is a major application of this device. This device collecting the data had transferred to the agri-sensor node, then transfer to the cloud, and then cloud to the users. User can manage the data. This is another case study. In this case study, you can see the cattle health monitoring system. In this system, you can see there is MSN on the neck of the animals. MSN mean multi-sensor nodes. Different multi-sensor nodes is attached on different animals so that we can measure body temperature, pulse rate, respiration rate, walking activities. So these are the function of this MSN sensor node to getting the data, to transfer the data, to producing the result to the user. Well, this is another advantage of the IoT field. In this, with the help of this sensor node, farmer can monitor the animal's positions and some physical activity. So this is another best feature of IoT, and this is another way of to process the data. This is another case study. In this case study, this is agriculture field of the farmer. In the farmer field, having different kind of sensors. You can see from the slide the function of sensors to collect the data, process the data, and then data can be managed by the user from anywhere. Here with a tab, with the help of tab, the data is managed by the farmer so that can be processed. And this is patient health monitoring system. I discussed earlier in the COVID pandemic, there was the biggest problem to move patients from one location to the another location. Then IoT was the best solution to resolve this kind of problem. In this, you can see patients having different kind of sensors. With the help of these sensors, data is collected, processed, and then transferred to the base station, transferred to the internet, and then transferred to the medical expert. So this is the huge impact of IoT in the COVID scenario, in pandemic scenario. Every time have to move patient was the problem, cost, timing, and different problems was resolved by the IoT system. This is case study for the smart home. In smart home, we can see today we have smart bulb, Alexa device, smart AC, smart fridge, smart camera. So these are some example of the devices and connected to the internet so that we can manage the data with the help of smartphone. These are some projects designed by our student in the Idea Lab. In this slide, you can see uh, these are the smart self-driving car. This is number recognition of the car. This is smart face recognition. This is smart agriculture, smart dustbin, smart streets, and many kinds of projects designed by the students and also participated in hackathon and also got the first position. And this is only possible the IoT lab in the Idea Lab in our college. This is, you can say, the future career in the IoT field. IoT basically is a combination of hardware and software. So everyone can go in the field of software and in the field of hardware. And as I discussed, the hardware is Arduino, Raspberry Pi, AMC. These are the major devices to processing the data, collecting the data. As we know, in Arduino there is microcontroller, and function of microcontroller is to control the environment, to sense the environment, to process the result, and produce some kind of result. And again, we have Raspberry Pi. Raspberry Pi is better than Arduino because Raspberry Pi is about 32-bit or we can say 64-bit devices. But Arduino is only 8-bit device, but we can design thousands of projects with the help of Arduino in the low cost because Arduino is about 4 to 600 devices, but Raspberry Pi is about 4 to 5,000 rupees devices so that we can control the data. This is only possible. So this is the future in the field of IoT and we can say in the field of solution architect, software engineer, embedded engineer, IoT cloud software development, IoT system administration, infrastructure, IoT test engineer. These are the features. Now, government is also helping in the field of IoT for the students so that students design some innovative idea like smart project, like smart agriculture, smart healthcare. These are the projects useful for the society so that government is starting some kind of startup so that providing some billion job for the engineer in the field of IoT. Now, these are the major vendor working behind the IoT field to designing some kind of hardware, to designing some kind of software. IBM, Google, Intel, everyone aware about the Intel. Intel full form is INT stands for integrated, EL stands for electronics. And Intel producing very small devices, intelligent devices, very small processor so that we can easily get the data, process the data and produce the results. Microsoft Cisco providing some kind of operating system, Cisco providing some routing protocols, routing devices. So these are the major vendors working for the IoT devices. These are the key technologies for IoT. If anyone wants to do something in the field of IoT, these are some kind of area where security, and we very well know security is always ongoing process. We are not able to provide full security. So security is the full path of the research. Future internet, knowledge aggregation, standardization, sensor network, communication protocol is there so that we can produce some kind of protocol so that we can publish good quality research paper. This is another part. Cloud computing, another part of the research so that we are able to produce good quality research, discovery service, nanoelectronics, embedded system, software, system integration. So if someone wants to do some good research, so there is different kind of parameters like speed, latency, security, throughput, so that we can get results with the help of different software. And software are like MATLAB, NS2, Contiki. These are the popular software where we can design some virtual environment and can can utilize some kind of protocol so that we can produce good result. And these are some challenges in IoT. If someone wants to get some data, yeah, some information about the IoT, then he or she will face some kind of problem. The challenges like security, very first problem. As we know, Gmail is using DTLS, DTLS security. DTLS security, data transport layer security. This is for the security of the transport layer, because transport layer is the only layer where security protocol is used to provide security of the data. Now, scalability, energy efficiency, bandwidth, modeling, interfacing, interoperability, data storage, data analytics, complexity management, different kind of challenges is present to enabling the field of IoT. Complexity of the network, yes, every day network is growing. So this is another problem, growth of the network, interfacing of the devices, network management, heterogeneity in the network, protocol standardization within the network. Because many vendor working in the field of IoT and they have own protocol, own standard. So there is the big problem to interface this kind of protocol, yeah, we can say these kind of standards. So this is about the complexity of the network. And in every field, there is lots of challenges, we know. So we have to do lots of research. We have to read lots of papers so that we can get the brief idea how to process in the field of different kind of research. Thank you. Thank you, everyone. Thank you, organizing team, to provide wonderful platform to spreading knowledge about the IoT and data analytics. If anyone has some question, he may ask. Hello.
Yeah, thank you, sir.
Thank you,
so
ma'am.
much. Participants, if you have any question, you can post your questions in the chat box.
Hello. Hello.
Hello.
Sir, can you please throw some light on the practical applications like the project which you do in academics using Arduino or NodeMCU or something like that, using some cloud, maybe UB.dots or ThinkSpeak, something like that. So what is it Arduino that you can use for the commercial purpose, or you are used for different Arduino or different sensors? Like for example, PR sensor, we use it. For testing purpose, we use a sensor, and for practical application for 24/7 running, you use different set of setups. Sir, if you could throw some lights on it, sir.
Sir, actually your voice is not clear. There is echo in your voice, sir. Can you write in chat?
Is it clear now?
Yes, sir.
Hello.
But there is heavy echo from your side, sir. I think you
signal problem, I think.
Yes,
can
sir.
I able to hear now? Can I able to hear now?
Yes, sir. Might be.
Little better?
Yes, sir. I think you are asking how we connect the devices to the cloud.
Yeah, that area about the practical applications, like we are doing some projects using Arduino or using NodeMCU or using linking the cloud and those things.
Yes,
so that same setup can be used for sort of a real-time application also.
Yes, sir. You can use with the help of ThinkSpeak. There is another cloud, is a Fire-based cloud. And if you want to some smarter application, then you can go AWS. This is smarter cloud, so that you can use for real-time application the project.
Oh, that's okay. Oh, anything about STM32 processor using now? So earlier used Arduino, now STM32 is used. So that is more practically used in industries.
Actually, sir, problem is voice, sir. Voice is
you're not getting my voice. Huh? Okay.
Yes,
Okay, sir. Thank you. Thank you.
You may contact me. I will give your my contact number so that you can contact me, sir.
Yeah, maybe you can post your, sir, maybe you can post your question in the chat box. Probably sir could read and answer your question.
Yes, yes.
I post a question. Hello.
Hello. Actually, in this, there is privacy is based on the policy. Actually, privacy, yes, is based on the policy. Policy means some kind of protocol, like if you are using TeamSpeak Cloud, so there is MQTT protocol, which provide the security of the user. So privacy is based on the policy.
Policy is based on the it's based on the because the privacy is not there is no special for things.
I am sharing my contact number.
Privacy, what the privacy based on the policy. The policies, the different policies are followed by a different region and different countries.
Ma'am, is there any question, ma'am?
I request the participants to provide your valuable feedback in the link which is provided. We have provided the feedback link in the chat box. Request all the participants to provide your valuable feedback in the link.
Madam, you are sharing all the PPTs later, madam?
Yes, sir, we'll share, sir.
Okay.
I will share, sir. I will share.
Okay.
Thank you, sir. Thank you, sir.
Thank you, ma'am. Thank you, everyone.
Yes, I can hear you. Participants, the feedback link is given in the chat box. Request all the participants to provide your valuable feedback. Okay. I deem it honor and privilege in proposing vote of thanks. First and foremost, I express my sincere gratitude to the management for providing such an opportunity for us, because I thank management because they are the strong pillar of support in all our endeavors. My heartfelt thanks to our Dean, College of Science and Humanities, SRM Institute of Science and Technology, Ramabram, Vice Principal Academics and Vice Principal Admin, and her head of the Department of MCA for the never-ending guidance and support. I take this opportunity to thank our Chief Guest, Professor Arun Kumar Rane, Panipat University, Haryana, for kindly accepting our invitation and enlightening us on IoT for modern digital era, data analytics with different case studies. Because sir started with the base like introduction to IoT, introduction to internet, and he taken the entire session with very lively. I would like to express my sincere gratitude to all the resource persons for the various technical sessions and the delegates for their enthusiastic participation in this PDP program. I acknowledge the unwavering support received from the faculty members and non-teaching staff. We assure the sessions ahead will also provide will be more beneficial to all the participants, and it will be more informative to all of us. Thank you, one and all. Thank you, sir.
Thank you, ma'am. Thank you very much. Thank you, everyone.
Thank you so much, sir. Sir, you can drop off. Thank you. Thank you so much. Participants, I'll give you another 5 to 10 minutes. I think the links is available in the chat box, requesting you all to give your valuable feedback.